You scroll past another headline about a killer who seemed completely normal, a neighbor, a coworker, someone's polite son. You feel a small flicker of relief. You tell yourself you could never be like that. But the real answer is far stranger than relief should allow. Your brain and the brain of a serial killer are not as different as you want them to be. Same neurons, same basic wiring, same chemical messengers carrying signals through the same kind of tissue. The difference isn't always what's there. Sometimes it's what's missing. In 2005, neuroscientist James Fallon was scanning the brains of murderers for a research project on Alzheimer's and violence. He was looking for patterns in the brains of psychopathic killers, comparing them against a control group of healthy volunteers. One of those control scans came back looking exactly like a killer's brain: low activity in the orbital cortex, reduced function in the amygdala, the classic signature he'd spent years learning to recognize in murderers. That scan belonged to him. Fallon had unknowingly included his own brain in the control group, and his scan matched the killers, not the healthy volunteers. He had the neural fingerprint of a psychopath, no history of violence, no criminal record, a successful career, a stable family, a normal life. What was missing? This is where you need to understand what that part of the brain actually does. The orbital cortex sits right behind your eyes. Think of it as your internal brake pedal. It's the region that steps in right before you act on an impulse, weighing consequences, holding back urges that would otherwise run wild. The amygdala, deep in the middle of your brain, is your alarm system. It's what makes you flinch at a scream, what floods you with dread when you imagine hurting someone, what generates the gut-level fear response that keeps most people from crossing certain lines. In Fallon's brain, both of these regions showed unusually low activity. In a true psychopath, that low activity often pairs with cold, antisocial behavior. In Fallon, it didn't. So what stopped him? Researcher Kent Kiehl, who has spent over a decade scanning the brains of incarcerated psychopaths using a mobile MRI machine, he drove into prisons across the country, found something that complicates the picture even further. Kiehl's scans of violent offenders consistently showed reduced gray matter in the paralimbic system, the network of brain regions tied to emotion regulation and moral reasoning. But Kiehl also found that brain structure alone never fully predicted behavior. Genetics loaded the gun. Something else pulled the trigger. That something else, according to both Fallon and Kiehl, often traces back to early life: abuse, neglect, chaos, violence witnessed young before the brain has finished forming its emotional architecture. Fallon, despite his brain scan, had none of that. He described a childhood full of warmth, attention, and stability. No abuse, no trauma, a buffer that, by his own theory, may have been the only thing standing between his neural wiring and a very different life. This is the part that should unsettle you. Brain structure is not destiny, but it is a loaded variable. And you don't get to choose the brain you're born with. Psychologist Hare spent decades trying to define what separates a psychopath from someone who is simply unpleasant or selfish. His psychopathy checklist, still used by clinicians and courts today, doesn't just look for violence. It looks for a cluster of traits: superficial charm, a grandiose sense of self, pathological lying, a lack of remorse, shallow emotional responses dressed up to look like real ones. Here's the unsettling part. Hare's research found that psychopathic traits exist on a spectrum, and a significant percentage of the general population scores moderately on his checklist without ever committing a violent crime. You've met people like this. Maybe you've worked for one. The charming manager who climbs the ladder by stepping on people without a flicker of guilt. The friend who lies effortlessly and never seems to feel it later. These traits don't require a knife or a prison sentence to exist. They just require an environment that lets them work. So if the wiring exists on a spectrum, and the environment shapes how it expresses itself, where does that leave you? Consider what happens in your own brain when you imagine causing someone pain. Most people feel an immediate, almost physical recoil. Researchers using fMRI have shown that when typical people imagine harming another person, their amygdala and orbital cortex light up together, producing a wave of discomfort that functions like an internal stop sign. In psychopaths, that same exercise produces almost nothing. The stop sign simply isn't there, or it's so dim it barely registers. That stop sign, the one most people never notice because it never stops firing, is doing more work than you realize. It's the reason you feel guilty after a small cruelty. It's the reason a raised voice from someone you love can ruin your whole day. It's the reason watching someone get hurt, even in a movie, makes you wince. Your brain is constantly running threat and harm simulations in the background, and for most people, those simulations come with an emotional cost built in. Now imagine that cost removed, not replaced with malice, just removed. No flinch, no wince, no internal alarm. What would be left to stop you? This is the uncomfortable territory both Fallon and Hare arrived at from different directions. Psychopathy isn't simply the presence of evil. It's often the absence of a break. And the break itself is built from a combination of genetics, brain structure, and early environment that none of us chose and few of us think about. Fallon eventually proposed something he called the warrior gene hypothesis, tied to a variant of the MAOA gene that regulates serotonin and has been linked in some studies to aggression when combined with childhood trauma. The gene alone didn't determine outcome. Neither did the brain structure alone. It was always the combination, biology meeting circumstance, that tipped the scale. You inherited your version of this same machinery. Your amygdala, your orbital cortex, your particular blend of genetic variants, all assembled before you had any say in the matter. Layered on top of that, your environment did its own shaping. Every harsh word, every act of comfort, every moment of safety or chaos in your early years adjusted the wiring just slightly. You didn't choose any of it. And yet it built the moral compass you now believe is entirely your own. This doesn't mean you're secretly dangerous. Most people, even those with traits scattered across Hare's checklist, never harm anyone. What it means is that the line between you and the people you read about in true crime headlines is not a wall. It's a gradient. A set of dials, some turned down low by chance, some turned up high by circumstance, none of them set by conscious choice. Fallon, to his credit, didn't end his story by claiming he was secretly a monster who got lucky. He ended it by arguing that nurture had quite possibly saved him. The stability, the attention, the absence of trauma in his early life may have compensated for a brain that, on paper, looked like it belonged to someone capable of real harm. That argument should change how you see every story you've ever judged from a distance. The killer who seemed so normal may not have been hiding a monster behind a mask. He may have simply had a brain tuned a little differently, shaped by an environment that never gave him the buffer Fallon happened to receive. This isn't an excuse. The checklist still distinguishes people who cause harm from people who don't, and consequences still matter, regardless of cause. But understanding the wiring changes the question you should be asking. Instead of asking what's wrong with them, you might ask what went right for you. What combination of brain chemistry and quiet, unremarkable safety kept your internal brake pedal functioning when someone else's never had the chance to develop one at all? So the next time you scroll past a headline and feel that flicker of relief, sit with it a little longer. You're not relieved because you're fundamentally different. You're relieved because, somewhere along the way, 1,000 invisible variables lined up in your favor. Different timing, different trauma, different brain scan, and the story in that headline could have had your name in it instead.